So recall that in real life situations, you may have to limit the domain to make answers reasonable. For example, quantities such as time, distance, and the number of people can be represented using only non-negative values, which means it's going to be represented using positive values, including 0. When both the domain and the range are limited to non-negative values, the function is graphed only in that first quadrant, quadrant 1. All right, so let's look at our first example. Example 4. So example 4 says that a mouse can run 3.5 meters per second. That's really fast. 3.5 meters per second? Like a meter, that's like more than a yard. So that would be like 3 yardsticks and then a half of a yardstick. That's in 1 second. That's really, really fast. The function is y equals 3.5x. Describes the distance in meters the mouse can run in x seconds. So what we have to do first is graph the function. So we're going to graph it using a table and plotting points. And then the second thing we're going to do is use the graph to estimate how many meters a mouse can run in 2.5 seconds. All right, so since we're talking about time and distance, we are not going to be dealing with any negative values. That's why our graph is just right here in the first quadrant. So when you do your homework, you want to make sure our x value is talking about seconds. So you want to label that x-axis as time. The y is talking about the distance. So you want to label that y-axis in distance. And you want to put a title on your graph. So we're talking, this whole graph is about the speed of a mouse. Okay, so the values I'm going to choose for my domain are, since we have to estimate 2.5, I'm just going to start with 0, 1, 2, 3, okay, because 2.5 will be in between the 2 and the 3. And then we're just going to go ahead and stick in these values in for x and figure out what the y values are. So y equals 3.5 times 0, which is just 0. So 0, 0 is our first point. Then I'm going to stick 1 in for 3.5, and 3.5 times 1 is just, 3.5. So 1, 3.5 would be our next. I'm going to use when x stick in, substitute x equaling 2 into our function. And 3.5 times 2 is just 3.5 plus 3.5, which is 7. So our next point is 2, 7. And then lastly, we have y equals 3.5 times 3, and I don't know what that is, so I'm going to take that off to the side. 3 times 5 is 15, write the 5, carry the 1. 3 times 3 is 9, plus 1 is 10. There's 1 decimal place, so our answer has to have 1 decimal place. So 10.5. All right, perfect. So we're going to go ahead and graph these ordered pairs. So we have 0, 0 first. Then we have 1, 3.5, which would be halfway between 3 and 4. And then 2, 7. And then 3 and 10.5, which would be right here. And then this is a continuous graph because time and distance and the mouse is running. So I'm just going to go ahead and draw that line here. Okay, so that is a graph of the function, and then we just need to do B, use the graph to estimate how many meters a mouse can run in 2.5 seconds. So I'm going to go right here to 2.5, which is halfway between 2 and 3, and just kind of go all the way up. And you see right there, it's 9. So I'm going to say the mouse can run 9 meters in 2.5 seconds. And there we go. Can you see that? Perfect, okay? So let's go ahead and look at another example. Check it out, example 4. So this says the fastest recorded Hawaiian lava flow moved at an average speed of 6 miles per hour. The function y equals 6x describes the distance y the lava moved on average in x hours. So the first thing we're going to do is graph the function. And then the second thing we're going to do is use the graph to estimate how many miles the lava moved after 5.5 hours. So the values that I'm going to choose for this one are going to be, first I'm going to choose 0, and then 1, 3, and 5. Only because we want to get close to that 5.5, and so I think that, you know, kind of spacing out the values will help us do that. Know that we're talking about time and the distance that that lava is traveling. So we have our x-axis and our y-axis labeled with the units because it's time in hours and distance in meters. And then we also have a lovely title, average speed of lava flow. So when you're doing your homework and you have application problems, you want to make sure that you label your axes just like this. Okay, let's go for it. Let's figure out what the these ordered pairs are so we can plot our graph. So we have y equals 6 times 0, right? I'm sticking 0 in for x. 6 times 0 is just 0, so that first point is 0, 0. Awesome. The next one is we're gonna stick 1 in for x, and we're gonna have 6 times 1, which is 6. So our ordered pair is 1, 6. And then there was 3. So we substitute 3 in for x here, and we get 6 times 3, which is 18. Which leaves us at this point. And then finally, when x is 5, we have y equals 6 times 5. 6 times 5 is 30, so that ends up with a point 530. Okay, then we're just going to plot these values. So we have 0, 0 here, 1, 6 here, 3, 18 here, and 530 right here. Okay. Perfect. And since we have our ordered pairs, now we're just going to go ahead and make that line. So I'm going to use a straight edge. Especially when we have to use this line to predict a value, you really want to use a straight edge so you can make your line accurate. And also you want to use graph paper as well. Okay. If you're using these lines for predictions, which we are doing. So we're going to go here. So that's our function. We graphed it. Awesome. Then for part B, we use the graph to estimate how many miles the lava moved after 5.5 hours. So 5.5 hours is halfway between 5 and 6, which is just right there. And I'm just going to kind of work my way up. And right there, it looks about, if we move over, 33. So we would say the lava moved 33, oh, this is in miles, not meters. Estimate how many miles. This is in miles. The lava moved 33 miles. That is a lot of miles. 33 miles in 5.5 hours. All right, perfect. That's how you solve those. So when you have a homework problem like this, make sure you have your table. Make sure you use graph paper. You label your x-axis, label your y-axis, you graph your ordered pairs, make the straight line, and then go ahead and make your prediction. And always answer the story problem in a complete sentence. All right, so that's it for this lesson. I will see you back in a little bit for Chapter 3, Lesson 5. All right, have a good day. Bye.